Hi, welcome to our math. Today I'm doing a series of videos on solving optimization problems with the Simplex method. To set up the Simplex method, what I need to do is I need to translate the system of equations into a matrix, but I need to add a few extra variables. I, of course, have my x sub 1 and my x sub 2, but I have to imagine a variable that makes up the difference between this and the 78. We'll call it a slack variable. So we have our first slack for our first equation, our second slack for our second equation, and then we're going to add our optimization variable to our list of variables in our matrix. My first equation is going to be 3x1 plus 5x2. It's going to get the first slack variable. And then we'll have our answer here at the end. My second equation, 4x1 plus x sub 2, it's going to get the second slack variable with a 36. And then I'm going to put my optimization formula next, but I'm going to take these variables and bring them over, subtract them over, so it's negative 15x sub 1 minus 11x sub 2 plus z equals 0, because if this is my augmented matrix, notice this is my equal sign and the z is to the left of the equal sign. So I get, and we'll make a line above our optimization line. So we have negative 15x sub 1, negative 11x sub 2, no slacks here, but a z, and it'll equal 0. Okay, so here's the process. We start by looking below the line, and if there are any negatives, we have another step to do. So we do have a negative, and we look for the largest negative, so negative 15. Okay, so this column becomes my pivot column. I'm going to find the ratios. I'm going to take 78 divided by 3, which is 26. I'm going to take 36 divided by 4, which is 9. Okay, so my ratio is the ratio of my answer column divided by the coefficients in my pivot column. We look for the smallest number, which is a 9, and this 4 becomes my pivot element. So just like when we're solving a matrix, what we're trying to do is we're trying to make the 3 and the 15 0 using this 4. Now, if you do a traditional simplex lesson, they'll say divide through by 4 to make this a unit, a 1, and use that 1. I don't tend to manipulate fractions. I figure matrices has enough going for it that I'm just going to keep the numbers as they are. I'm just going to say 4 times row 1 minus 3 times row 2, and I'm going to put that into row 1. So 4 times row 1 is going to be 12, 20, 4, 0, 0, 3, 12. Negative 3 times row 2 is going to be a negative 12, negative 3, 0, negative 3, 0, negative 108. And when we add these together, I'm going to get a 0, 17, 4, negative 3, 0, 204. Okay, now to get rid of the 15 using that 4, I'm going to do 15 row 2 plus 4 row 3 and replace that into row 3. Okay, so to do this, I'm going to do 15 row 2, and 15 row 2 is going to be 60, 15, 0, 15, 0, 540. And then I'm going to do 4 times row 3. 4 times row 3 is going to be a negative 60, a negative 44, 0, 0, 4, and 0. When I add down, I'm going to get a 0, negative 29, 0, 15, 4, and 540. Okay, so now I'm going to put together my next matrix. My first row is going, and I'm going to have the same columns. I'm going to have x sub 1, x sub 2, slack 1, slack 2, and z. My first row becomes this row, this 0, 17, 4, negative 3, 0, 204. My second row stays the same, 4, 1, 0, 1, 0, 36, and my last row is going to become this new last row. 0, negative 29, 0, 15, 4, 540. Okay, so now here is my second Simplex Tableau. Once again, what I said before is whenever there was a negative below the line, we have work to do. So if we look at my next Tableau, I have a negative 29. Once again, I'm going to do these ratios, answer divided by column. So 204 divided by 17 is 12. 36 divided by 1 is 36. And once again, we're looking for the smaller ratio, which is this 12. So we are going to pivot on this 17. Again, traditional matrix manipulation says divide by 17 and play around with fractions. The way I do matrices, I will get the fractions, but not until my very last step. Okay, so what I'm going to do next is I'm going to use a 17 to get rid of this 1. So I'm going to say 17 row 2 minus row 1. 17 row 2 is 68, 17, 0, 17, 0, 612. Minus row 1, 0, negative 17, negative 4, 3, 0, negative 204. And when I add these together, I'm going to get 68, 0, negative 4, 20, 0, 408. To use the 17 to get rid of the 29, I'm going to get obnoxiously big numbers. I admit this. It's okay. I am going to do 29 row 1 plus 17 row 3. And I'm going to put that into row 3. This is going into row 2. Okay, so 29 row 1. 29 row 1 is going to be 0, 493, 116, negative 87, 0, and 5,916. 17 row 3. 17 row 3 is going to be 0, negative 493, 0, 255, 68, and 9,180. And when I add these together, I'm going to get a 0, 0, 116, 168, 68, and 15,096. Okay, when I put these together, my first row is going to stay the same. I'm just going to do this over here. So my first row is going to stay 0, 17, 4, negative 3, 0, 204. My second row is going to become this one. So the 68, 0, negative 420, 0, 408. My third row is going to become 0, 0, 116, 168, 68, 15,096. Okay, so we now do not have any zeros below the line. So now we are going to bring about our fractions. What we're going to look for are what are going to become unit columns. The unit columns are columns that have a number, a single number, and everything else zeros. There are at most 3 in this one. And to make this a unit column, I need to divide this second row by 68. Okay, to make this a unit column, I need to divide the first row by 17. And to make the bottom row unit column, I need to again divide by 68. If I divide the first row by 17, I get 0, 1, 4 seventeenths, negative 3 seventeenths, 0, and 12. If I divide the second row by 68, I get 1, 0, negative 1 17th, 5 seventeenths, 0, and 6. And if I divide the bottom row by 68, I get 0, 0, 29 seventeenths, 42 seventeenths, 1 and 222. Okay, so now this is our final tableau. This is my x sub 1 column, my x sub 2, slack, slack, z. So how this reads, this is a unit column. A unit column translates to, let's see, x sub 1 is a unit column, so x sub 1 has a value that isn't 0. The value for x sub 1 is 6. X sub 2 is a unit column. Because x sub 2 is a unit column, x sub 2 has a value that isn't 0. It is 12. Slack 1 is not unit, so this would actually end up getting the value of 0. Slack 2 isn't a unit, so it gets the value of 0. Z is a unit. Z is a unit whose value is 222. So my final answer for maximizing this is the maximum is Z equals 222 at 612. There we go. I hope you enjoyed this video. Please subscribe to my YouTube channel, like my Facebook page, and I'll see you on the next video. Thanks.